Hi everyone. If we've not met before, my name is Namdi. I'll be doing a demo of the LLM Experiments Lab, and this is for the Nebius Serverless AI Challenge. Um, this solution, which is called LLM Experiments Lab, was inspired by my time on the Nebius Academy AI Performance Engineering Fellowship, which I was on earlier this year for about 14 weeks. We're about two or 300 of us. We had classes in a mix of different modules, ranging from LLM architectures, performance engineering, MLOps, and post-training. So I think I should start off with what problem we're trying to solve. So essentially, it's all about people people learning about large language models and how they work. And I think the best way to do that is really by playing and experimenting. The current solutions for doing this are kind of twofold. The first is very theory heavy, very mathematical, requiring knowledge and experience of NLP. And then the other is much more, it's quite code heavy. You need to be able to, you're either using Python scripts or you're using Google Colab. You're having to write the code, write your class definitions, forward passes, run a trainer, hyperparameter tuning, those kind of things. And even if you don't have a GPU at home, you might have to provision GPUs on cloud. And so you need that kind of cloud ops experience. So we feel these two kind of approaches I kind of don't make understanding LLMs accessible to the average person. And hence the need for LLM Experiments Lab, which is a browser-based solution. It does involve you really knowing how to code or knowing how to provision hardware. Right, okay, so without further ado, I'm going to start showing you more about this. If you look at the screen, this is the landing page. You pick whether you want to run on a CPU or a GPU, and then you pick a backend you want to use. You can use your local backend, i.e. your computer, or you can use a serverless endpoint like provided by Nebius. So we'll select that, and then you pick one of these presets. This is different experiments which we've loaded onto the platform. They're all based on transformers, apart from that one which is based on recurrent neural networks. So if we go for mixture of experts, we'll pick that one. And sorry, we'll pick GPU just to make things faster. So yeah, so this is this is the lab dashboard, and you've on the left hand pane you've got your config, you've got model config, just like how big the network is and how big the tensors are and those kind of things. And then you've got training parameters there, how big your batches are, how many iterations you do, what optimizer you use. And then at the bottom you've got inference parameters. So when you're inferencing, when you pause the model to prompt it, how, what parameters, what temperature, what max new tokens, and that sort of thing. So I'm just going to illustrate this, I'm going to change the number of layers to 5. So here, this is the architecture. You've got your embedding layer at the start, then the transformer, and then the final layer norm, and then the language model head that does the prediction of what character comes next. Now that transformer then splits, it actually has 5 blocks which are kind of identical, and these are the elements in each block. So when I made that number layers 5, this went from being 4 to being 5, so we end up having 5 blocks. So with that, I'm going to start training, and just press that. And so the job gets queued, and because the endpoint is up, it's actually already running. So that's the hardware being used. It's an L40 single GPU, 8 virtual CPUs, and 32 gigabytes serverless. So this is the step counter. We're doing 1,000 steps, and it's moving pretty quickly. When it gets about halfway, we'll kind of stop it and try prompting, looking at the loss curves and prompting the model. So we can pause it. Yeah, that's 560. So these are the loss curves. Loss is reducing, which is good, shows that training is happening, the model is learning. And this is the expert drop rate and just shows these experts and how effective or efficient they are. Right, okay, so we're going to prompt the model, and I'll just type something very basic like, I'll type good morning with an exclamation. Now, to prompt the model, we've got two modes. We can go one step at a time, so it's just producing one character at a time, or we can go continuous generation, which will go right to the end of 100 tokens. We've got a max new tokens budget of 100. So we can do either of them. And I think I forgot to mention that this transformer model is a character level transformer model. So the predictions are one character at a time. So you probably would have heard about word level transformers where they predict one word at a time, but this is just one token at a time. Right, okay, so let's start. One click. It runs. Another one. It runs step 2. Okay, there's a character K. So the previous ones were spaces, that's why we didn't see anything. Or actually new lines rather than spaces, that's why we didn't see anything. So we can continue typing or stepping. And then the other thing we can do is, on the right hand side, there's this inspector pane, which has a lot of diagnostics, and so you can see it kind of streams all the kind of data from the network. So your tensor metrics, your logits at the language model head, and all the vectors and so on and so forth. So if we click that and we look there, you can see at the end you've gotten to 18 tokens, and I think you've added 6, and you probably had 12 to start with, or maybe 13. So it's saying the current character is N, and it's predicting C, which has an ID of 15, but we can't see that here. So let's just do another step. Another step. Right, okay, so another step. We've gotten to a small O, and so H was the character before, and it predicted a small O. You see that's in green because that was the highest logit, 55.4%, etc. So, I mean, this just gives you an understanding or an insight into what the model's doing. So that was just the logit head, but the LM head, but the other parts of the transformer, this is the layer before. It's called the final layer norm. We show the shapes of the tensors, some stats of the layer, and then the inputs and outputs kind of states, the kind of residual states. So you can hover over this, you see the full value, or you can double click there, and it takes the full thing. You can copy that and paste it in Excel or Word or wherever. So I'll close that, takes you back there. You also have the self-attention layer. So this is an attention heat map. These are the characters we've seen. You can move the position. There's a stepper there, you can move it. But these are the last characters. If you look there, O, H, and C. Here you see O, H, and C. So this is the heat map showing the attention mechanism. And below we've got Q, K, and V vectors. The last thing I'm going to show you, or the second to last thing, is the assistant. It's a grounded chatbot, and it has tools, and it can search files, and it can help you. So you can just ask it, how was the training run? See what it comes back with. It's taking a while to come back, and yeah, it has to do a bit of thinking. So it comes back, tells you about the loss, And it tells you about the hardware, it tells you about the network, and a few other things. So you can carry on asking it questions. Last thing I'll show you is below here, you've got some code files which you can inspect, the model definitions and how it's run. And then last thing here is metrics, which is training metrics and resource metrics like GPU utilization and GPU RAM utilization. Right, okay, so this is the LLM Experiments Lab, and I hope you've learnt a bit about it today. In the comments, I'll put down a link to the GitHub, as well as a blog I wrote about it. And yeah, so I look forward to you trying this out. Like I said, it's a no-code, browser-based solution. It's cost-efficient. You don't need to go and buy a GPU or run one permanently. You just use it for when you need. And it's very transparent, and it can really give you a lot of help and insight into what's going on. Okay, thank you very much, and hope to get comments